So in this particular segment, we wish to discuss about the properties of areas of similar triangles. Okay, so the focus of the discussion is going to be what is the relation between areas of two similar triangles. But to understand this, we need to understand a few more properties. What is the ratio of perimeter of two similar triangles? Then we also wish to understand the ratio of the corresponding medians. We also wish to understand the ratio of the corresponding altitudes of two similar triangles, right? And we also wish to understand the relation between the ratio of two angle bisectors of two similar triangles. So the discussion in this particular video is going to revolve around two triangles which are already similar. We know that they are similar to each other. And just to revise quickly the different tests for similarity, were the first test was SSS, right? So we had the SSS test for similarity, where we said that if two triangles will be similar if the ratio of all their three sides are equal to each other. The other test for similarity was SAS test, and the third test for similarity was the AA test, right? So these are the three different tests for similarity. And when two triangles are similar, so let us recap these concepts. If two triangles, say ABC, is similar to triangle DEF, then we know that angle A becomes equal to angle D, then angle B equals angle E, and angle C equals angle F. Similarly, AB divided by DE is equal to BC divided by EF, which is equal to AC divided by DF. So this is called corresponding angles of similar triangles, and its short form is CAST, and this is known as corresponding sides of similar triangles, which is CSST, right? Therefore, these are some important concepts of similarity that we will be using to investigate the properties that we want to discuss in the video today. Okay, so let's now start with two triangles which are similar to each other. So in the figure shown over here, right, there are two triangles that are shown over here. Let's assume that triangle ABC is similar to triangle PQR. Let us assume that this is given to us. Okay, so now we are interested in finding the ratio of all these parameters in these two similar triangles. The first thing that I'm going to do is, because these two triangles are similar, I know that the ratio of their corresponding sides is equal, which means AB divided by PQ is equal to BC divided by QR, which is equal to AC divided by PR, which is say equal to K, right? And this K is going to be called as the scaling factor. So what this scaling factor essentially means is by what number are all these sides being multiplied to get the new triangle. So this means AB upon PQ, AB upon PQ is equal to K, which would imply AB is equal to K times PQ. So let's assume that the side PQ is X. If the side PQ is X, then AB is going to be K multiplied by X, right? So the side PQ got multiplied by K and it became the side AB. Now similarly, if side QR is Y, right? If side QR is Y, then I know that because PQ got multiplied by K and it became KX, similarly, the base BC is also going to become K times Y. And suppose PR is equal to Z, then the side AC is going to become K times that Z. So this side becomes K into Z. So what has happened is all the sides have been multiplied by the same scaling factor, which is K. Okay. While at the same time, let's understand all the angles are equal to each other, which means the two red dots are equal to each other. The two angles marked with purple dots are equal to each other, and the two angles marked with black color, or let's pick a different color, say with the yellow color, the two dots with yellow color are also equal to each other. This is the property of similar triangles. So what has happened is I have first had triangle PQR with sides X, Y and Z. The triangle is now being scaled up by a factor of K. That means all the sides are being multiplied by K, and because the sides are being multiplied by K, this side X has become KX, the side Y has become KY, and the side Z has become KZ. So I want you to understand this diagram first and this idea first, and then I will continue. Okay, so now I'm interested in finding what is the ratio of their perimeter. So first of all, what is the perimeter of triangle PQR? Perimeter is nothing but sum of all the sides. So perimeter is X plus Y plus Z, right? It is basically the sum of all sides. That is the perimeter of triangle PQR. Similarly, what is the perimeter? What is the perimeter of triangle ABC? The perimeter of triangle ABC is again going to be the sum of sides of a triangle ABC. So it is going to be KX plus KY plus KZ. What is common in these two, in this particular trinomial? K is common. I can pull K out. So this is K times X plus Y plus Z. And now if you notice this X plus Y plus Z term, the X plus Y plus Z term is nothing but the perimeter of triangle PQR. So what I can conclude from this is the perimeter of triangle ABC, the perimeter of triangle ABC is equal to K times perimeter of triangle PQR, which in turn means that perimeter of triangle ABC divided by perimeter of triangle PQR is equal to K. And what this means is, in whatever ratio the sides are being multiplied by, the perimeter also scales by the same factor. So this is the first important conclusion that we have reached. If you are multiplying all sides by a factor of 3, then the perimeter will also get multiplied by a factor of 3. So if you have a triangle whose perimeter is say 50 centimeters, so suppose you have a triangle whose perimeter is say triangle perimeter is say 50 centimeters and you are doubling all the sides, then the perimeter of the new triangle will become 50 times 2, that is 100 centimeters. Okay, so the perimeter scales by the same factor as the sides. This is an important conclusion. I am again pausing for a minute and then we will continue with the next concept. Okay, let us now visit the next concept, which is the ratio of the altitudes. So again, I assume the same figure. I have triangle ABC is similar to triangle PQR, that's given to me. And because the triangles are similar, I know that the ratio of the sides are equal, right? So this is what I've shown here. And I've assumed that that particular ratio is K. Okay, that is called the scaling factor. So that means AB upon PQ is K, which means AB will be K times PQ. So if I assume the sides of the triangle as X, Y and Z, then PQ is getting multiplied by K to become AB. Okay, so AB therefore becomes K times X. QR corresponds to side BC. So if QR is Y, QR is getting multiplied by K to become KY. And similarly, AC is PR multiplied by K. So PR is Z and therefore AC becomes K times Z, right? So these are the three triangles, these are the three sides that I have in triangle ABC, KX, KY and KZ. Now what I'm doing is I'm interested in finding the ratio of the altitudes. Okay, so I know that the side QR corresponds to BC and the point A corresponds to P. Okay, so from P, I am going to drop a perpendicular down. That means this PM is say perpendicular to AN. Okay, these are the two perpendiculars drawn. So let us label them quickly. So this is say AN. This point is N and this point is say equal to M. Okay. Now what I'm going to do is I'm going to consider these two triangles for similarity. By the way, let me explain what I'm trying to do. I'm trying to find the ratio of these two corresponding altitudes. Why are they the corresponding altitudes? They are the corresponding altitudes because the side BC corresponds to QR and the vertex A corresponds to vertex P. That is why AN and PM are the corresponding altitudes, right? Because BC is the corresponding side of QR and vertex A coincides with vertex P. That is why AN and PM are the corresponding altitudes. So now what I'm going to do is I'm going to consider, so let us consider triangle ABN and triangle PQM for similarity. Let us see if they are similar to each other. Now I know that angle B is equal to angle Q. Okay. And similarly, I have two right angles over here. Angle BNA is 90 degrees and angle QMP is also 90 degrees. That means by AA test, angle test, these two triangles are similar to each other. So I know that angle ABN is equal to angle PQM because this is given. Why is this given? Because the original triangles are similar, right? I know that triangle ABC and triangle PQR are similar, which means that angle B is equal to angle Q. I know this. And therefore, I can also say that angle ANB is equal to angle PMQ, which is equal to 90 degrees, right? So now I can say that by AA test, I can say that triangle ABN is similar to triangle. Now B corresponds to Q, B is the second letter, so Q is also the second letter. N is 90 degrees, here M is 90 degrees. So those two vertices will correspond and the third vertex is going to be P by the AA test. And because these are similar now, I can say that AB divided by PQ is equal to BN divided by QN, which is equal to AN divided by PM. Right? So AB are the first two letters, PQ are the first two letters. So AB by PQ is equal to BN is the second and third vertex, QM is the second and third vertex, and then A and N are the last vertices, first and last ones, and P and M are also the first and last vertices. This is because corresponding sides of similar triangles. Now, let's substitute the values. How much is AB? If you look at the diagram, AB is equal to KX. And how much is PQ? PQ is equal to X. This equals AN divided by PM. So now X cancels, right? The terms X cancel. This means AN divided by PM is also equal to K. I think that's a very important thing that we have just found out. What it is telling me is if the sides are scaling by a factor of K, then the corresponding altitude, so from this I can say that AN is K times PM, right? So the altitude AN is also scaling by a factor of K, which means this altitude is H. Then the altitude AN, so PM I have taken as H. So the altitude AN will be K times H. So what it means is the altitudes will also scale by the same factor as the sides. This is a very important idea that we have reached. Let me just summarize it in the bracket over in the box over here. So what it means is earlier we found that the perimeter of two similar triangles, in two similar triangles, we earlier found out that perimeter 1 by perimeter 2, that is the ratio of the perimeters of two triangles, was equal to the scaling factor K. And now we have found out that the altitudes of two similar triangles is also scaling by a factor of K. That means if the sides get doubled, the corresponding angles also get doubled. Corresponding altitudes also get doubled. Whereas if the sides become 10 times, the corresponding altitudes will also become 10 times. If a triangle is scaled by a factor of 1 by 3, that is if it is made smaller, then all altitudes will also scale by a factor of 1 by 3. This is a very important conclusion that we have reached, and I would like to pause for a minute and then continue with the next part. Okay, so now in the next section, I would like to continue with the ratio of their areas. So let's find out more on that. So now we are interested in finding the ratio of their areas. Okay, so again these two triangles are similar. So it's given that triangle ABC is similar to triangle PQR, that is given to me, and the scaling factor is again K. So the sides are X, Y and Z. These sides X, Y and Z have been zoomed to sides Kx, Ky and Kz. And we just now learned that the altitudes also scale by the same factor, right? So if the altitude here is H, then the altitude of triangle ABC becomes K times H. So now if you start finding the area of triangle ABC, we know that area of a triangle is given by half into base into height. So what is the area of triangle ABC? Area of triangle ABC will be given by half into the base. The base is Ky in this case, multiplied by the height, which is Kh. Similarly, the area of triangle PQR is given by half into, what is the base here? The base is QR, which is Y, times the height, which is H, right? Therefore, I have area of triangle ABC by area of triangle PQR. If I decide to find their ratio, so area of triangle ABC, the whole divided by area of triangle PQR. Let us see what it means now. Area of triangle PQR. This is going to be half into Ky into Kh, the whole divided by half into Y into H, right? And now what will happen is half cancels, Y will also cancel, and H also cancels. Therefore, K into K becomes K square. Therefore, I can say that area of triangle ABC divided by area of triangle PQR is given by the square of the scaling factor. So this is another important thing that we have noticed here, that if the sides say double, then the ratio of the perimeter is 2. The ratio of their altitudes is also 2:1. But the area will scale by 2 square, that is by 4 times. So the area doesn't scale by just the scaling factor. The area scales by the square of the scaling factor. This is a very important idea that we have reached. Now let's note down all the conclusions that we have so far. Okay, assume that two triangles are similar to each other. So if two triangles are similar and say K is the scaling factor, then the ratio of their perimeters, so perimeter of triangle 1 by perimeter of triangle 2 is equal to the ratio of their corresponding altitudes, which is H1 by H2, which is nothing but K, right? So the ratio of the perimeter and the ratio of the altitude remains K, whereas right now we just saw that area of triangle 1 by area of triangle 2 won't be K, it will be K square. That is, the area scales by the square of the scaling factor. Now I am going to show you this particular concept with an example of a triangle as well as rectangle. Okay. So now let's consider two rectangles. So ABCD is the larger rectangle. So ABCD is the larger rectangle, whereas CPQR is the smaller rectangle. Let us assume that the side AB is 10 centimeters and QR is 5 centimeters. Similarly, let's assume that RC is 2 centimeters and BR is also 2 centimeters. Now these two rectangles are similar to each other. Why are they similar to each other? You will notice that QR when doubled, when QR is doubled, it gives me AB. Whereas when CR is doubled, it gives me BC, right? So when QR is doubled, 5 centimeter doubled becomes 10 centimeter. That's the side AB. And similarly, RC when doubled, so RC is 2 centimeter. When RC is doubled, you get 4 centimeters, which is BC. That is why these two rectangles are similar to each other. Let us now find the area of rectangle ABCD. So area of a rectangle is given by side, that's length 10. Length is 10 multiplied by the breadth. Breadth is 4. Therefore, the area becomes 40 square centimeter. And let's find the area of rectangle PQRC. So the length of PQRC is 5 and the breadth of PQRC is 2. So 5 2s are 10 square centimeter. Now let us find the scaling factor. What is the scaling factor here? Scaling factor is basically the ratio of their corresponding sides. That's going to be 10 upon 5. So the scaling factor here is 2. So the sides of the smaller rectangle have been doubled to get the larger rectangle. That is what it means. Now let's find the ratio of the area. So area of rectangle ABCD. So area of rectangle ABCD divided by area of rectangle PQRC is given by 40 divided by 10, which is 4, and 4 is nothing but square of 2, right? So the ratio of the areas is square of the scaling factors. That particular idea has been proved in this particular problem. Now let's find the perimeter of rectangle ABCD. So perimeter of rectangle ABCD will be given by 10 plus 4 is 14. 14 2s are 28 centimeters. And let's find the perimeter of rectangle PQRC. So the rectangle of PQRC will be 5 plus 2 is 7. 7 plus 7 is 14. And the ratio of their perimeters, so perimeter of ABCD divided by perimeter of PQRC will be 28 divided by 14. Now 28 divided by 14 is 2, and therefore you will notice here that the ratio of perimeters is the scaling factor, whereas ratio of the areas is the square of the scaling factor. So I'll just pause for a minute for you to look at this diagram, and then let's try the same thing with a triangle. Okay, now let us try a similar problem with rectangles. Let us now consider these two triangles with sides 3, 4 and 5 and sides 9, 12 and 15. You must notice that all the sides have been multiplied by a factor of 3. So 3 centimeter has become 9 centimeter, 4 centimeter has become 12 centimeter, and 5 centimeter has become 15 centimeters, right? So the scaling factor here, the scaling factor K is equal to 3. Now it's easy to notice that these are indeed right angle triangles because these are very well known Pythagorean triplets. So I can find the perimeter of the triangle 1. Perimeter of triangle 1 is 3 plus 4 plus 5, which is 12 centimeters. And the perimeter of triangle 2 is going to be 9 plus 12 plus 15. So 9 plus 12 plus 15. That's going to be 36 centimeters. The area of triangle 1, is going to be half into base into height. That's half into 3 into 4, which is 6 square centimeters. And area of triangle 2 is given by half into 9 into 12, okay, which is 108 by 2 is 54 square centimeters. So now if you were to find the ratio of their perimeters, let's do that. Let's find perimeter of triangle 1 by perimeter of triangle 2. That is 12 upon 36, which is 1 by 3, which means perimeter of triangle 2 by perimeter of triangle 1 is 3 upon 1. And here also side 2 by side 1 is 3 upon 1. So this tells me that the perimeter scales by the same factor as the sides. So if sides have tripled, the perimeter has also tripled. Similarly, let's find the ratio of their area. So let's find area of triangle 2 by area of triangle 1. This is going to be 54 by 6, which is 9:1. And 9:1 is nothing but the squaring factor of the square of the scaling factor. The scaling factor is 3:1. So the square of that factor is going to be 9:1. So this proves that area scales by the square of the scaling factor, while the perimeter and altitude scale by just the scaling factor. So now let's go back to the remaining two parts regarding the median as well as the angle bisector, and let us see what are the observations over there. So again, let us now consider two triangles as shown in the figure here. They are similar to each other. So triangle ABC is similar to triangle PQR. And the sides AB, BC and AC are marked by X, Y and Z. K is the scaling factor. So K is my scaling factor, which means the sides X, Y and Z have been multiplied by K to get the sides PQ, QR and PR. So the sides are KX, KY and KZ. Now what I'm trying to do is I'm trying to find the ratio of their corresponding angle bisectors. So let me draw the angle bisector of A as in here, and let me also draw the angle bisector of angle P. Okay, so I've drawn the angle bisector. So now because the triangles are similar, I can say that angle B has to be equal to angle Q because the triangles are similar. And the whole of angle A should be equal to the whole of angle P. Again, because these are the corresponding angles of these similar triangles. So now what I'm going to do is I'm going to mark the corresponding angles. Okay, let me shade them. So angle A is equal to angle Q And I know that whole of angle A is equal to whole of angle P because the triangles are similar. Let me use a different color. Okay. Now if complete angle A is equal to complete angle P and AN or AM, let's mark the angle bisector. So this is M and this is N. So AM bisects angle A and PN bisects angle P. Now angle A and angle P are equal, that is given to me. So half of their angles, that is this angle, angle BAM, should also be equal to angle QPN, right? We learned this in our Euclid's postulate. So what I'm trying to say is, I'm saying that consider triangle ABY and triangle AABM and PQN for similarity. Okay, let us see what all quantities are equal. First of all, angle B is equal to angle Q, and this is because triangle ABC is similar to triangle PQR. Secondly, I know that complete angle A, that is angle BA, so I know that angle BAC is equal to angle QPR. This implies half of angle BAC should be equal to half of angle QPR. Now what is half of angle BAC? Half of angle BAC is nothing but angle BAM should be equal to angle QPN. Which means that the two triangles, triangle ABM is going to be similar to triangle PQN by the AA test, right? And therefore AB divided by PQ will be equal to AM divided by PN. Now what is AB? AB is X. So let us now substitute the different values of sides. AB is X and PQ is KX is equal to AM divided by PN. Now XX cancels, which means PN is K times AM. So what it means is, if AM is equal to say the variable, let's take say F, then Pn will be equal to K times F. So what this is telling me is the angle bisectors are also scaling by the same factor as the sides. So let us quickly summarize what all we have learned so far. We learned that if two triangles are similar, let us quickly note that in the box over here. So we learned that if two triangles are similar, if two triangles are similar with the scaling factor as K, with scaling factor of K, then the ratio of the altitudes, that's h1 by h2, is equal to the ratio of their perimeters, which is p1 by p2. It is also equal to the ratio of their angle bisectors, which is ab1 by ab2, which is equal to k basically. Yeah. So k is nothing but the ratio of the sides, so that's s1 by s2. So the ratio of the altitudes is same as the ratio of the perimeter, is same as the ratio of the angle bisectors, is the same as the ratio of sides, but the ratio of areas is equal to k square. That is, the area scales by the square of the scaling factor. This is what we have learned so far, and now we would like to move on to the ratio of the medians. Okay, let us now go and see what happens to the ratio of the medians. So let us consider two triangles which are similar to each other, triangle ABC and triangle PQR. Let's assume that the sides of the triangle ABC are x, y and z, and the triangle has been scaled by a factor of k. So the sides have become kx, ky and kz. Now what I'm going to do is I'm going to draw a median from A. Now median means it will intersect BC and QR at its midpoints, right? So let's mark this as M and this as N. Now M is the midpoint of BC. That means the length BM is equal to y divided by 2 because M is the midpoint of BC. Similarly, QR is ky, and therefore the length of QN will be equal to ky divided by 2, right? So this length is k into y divided by 2 because again n is the midpoint of QR. Now if you consider these two triangles for similarity, okay, the triangles that I'm shading right now, let's see what happens. We have, so consider triangle ABM and triangle PQN for similarity, right? Now we have AB divided by PQ is equal to x divided by kx, that equals 1 by k. Similarly, BM divided by QN is equal to y divided by 2 divided by ky divided by 2. So that is y by 2 into 2 upon ky. Now 2 cancels and y cancels. So this also is 1 by k. So this implies AB by PQ is equal to BM by QN. So what I mean to say is the ratio of these two sides are equal, and we also know that angle B is equal to angle Q because the original triangles are similar. Therefore, the two triangles are similar by the SAS test because these two sides are in the same ratio as the sides BM and QN, and the included angles are equal, right? So by the definition of SAS test, if two sides are in the same proportion if two sides are in the same ratio and the included angle is equal, then the two triangles are similar. So ABM is similar to triangle PQN, and what it means is AB divided by PQ is equal to AM divided by PN. Now AB upon PQ is basically the ratio in which the sides are scaling, and AM upon PN is the ratio of the medians. So what this means is in two similar triangles, the medians also scale in the same ratio as the sides, which is the scaling factor, right? So so far we have learned that the perimeter, the angle bisector, the median and the altitude, they all scale in the same they scale by the same factor as the sides, but the area scales by the square of the scaling factor. So that is how area scales by a different value as compared to all these quantities. So let me again pause for a minute, and if there are any questions we can definitely discuss. Otherwise we will just summarize and conclude the discussion. Okay, so let us summarize now. If two triangles are similar, so let us summarize now. If two triangles are similar with a scaling factor of k, then the ratio of their perimeters, so perimeter of triangle 1 divided by perimeter of triangle 2 is equal to the median of triangle 1, medians of triangle 1 divided by the medians of triangle 2, and it is important that you should pick the corresponding medians, is equal to the altitudes of triangle 1 upon altitudes of triangle 2, which is equal to the angle bisector of triangle 1 by angle bisector of triangle 2. All these ratios will be equal to k, whereas the area of triangle 1 divided by the area of triangle 2 will be equal to k square, the square of the scaling factor. So when the triangles are similar, this is the property for areas that we should be using. Okay. Whereas if the triangles are not similar, then we have learned in one of our earlier sections that if two triangles have the same base, then the ratio of their areas is the ratio of their altitudes, so h1 by h2. Whereas if two triangles have same altitude, then the ratio of their areas is the ratio of their bases, that's b1 by b2. If two triangles have same base and same altitude, then the areas are equal to each other. Whereas if two triangles have different base and altitude, then the ratio of their areas, that is a1 by a2, is the ratio of their bases, multiplied by the ratio of their altitudes. And lastly, if the two triangles are similar, then the ratio of their area is the square of the scaling factor, right? So these are the different conclusions that we have reached as far as the areas of triangles are concerned. So I'm going to pause for a minute so that you can take photos if you want, and you can digest the information on the board, and that concludes the session for today. Okay, so this concludes today's session.